Instructor session on week 1 contents of ML practices course. I would request you all to please open some ID, let's say Google Colab at your end, so that you can code along with me, and I will give you certain tasks and you can do along with me. Let me share my screen. Okay, so in the last session, we had ran over the collabs which were used for recording. There are 3 components in week 1. We are demonstrating an ML end-to-end example, which is just for knowing the sequence of steps that maybe take place. Don't worry about all the libraries that are being used there. I highlighted this earlier also. As you would have seen, week 2 is a detailed one on pre-processing. Similarly, the subsequent weeks will be having in-depth detail on different other libraries, different models, classification and regression. So other than ML end-to-end model demonstration, what else is there in week 1 is data loading and of course an introduction to sklearn library. So data loading is the most important thing that you should be practicing in week 1. So we had covered the activity questions in the last session. So now we would start off with the practice questions. So I hope you can see the practice questions on the screen. So we would be now coding and we would be getting an answer to these questions. So this would be the general format in ML practices. Activity questions would be straightforward, but practice and graded questions would require you to code, and through the code you will be getting an answer that you'll be feeding in here. So looking at the first question, which of the following options are the class names in the iris dataset? So I think we discussed it last time, how to load the datasets from sklearn. So there are some toy datasets available in sklearn as a part of sklearn library, and like iris is one of them. So how do we load this iris data? So let's see, from sklearn.datasets. This is the library that contains different datasets in sklearn. So from sklearn.datasets, we'll do import load iris. Okay, I hope you're also doing at your end, so that you are able to answer the practice questions yourself and hence subsequently do the graded assignment questions. So we imported this library, and then what we're going to do is we're going to create an object of load iris. Okay, so let's say we name the object as iris, and then we would load this data. All right. Can somebody confirm? Can you please confirm that you have reached this till this point?
Yes.
So I asked.
Yes, ma'am.
Okay, good. Now, can you tell me the type of this object that you have created?
Bunch object.
Okay, what is a bunch object?
It's a dictionary where we have features and labels as these keys.
Okay, it's a bunch object. It's basically sort of a dictionary with 2 things. One is the feature matrix and second is the target. So there is another way. All right. So can you tell me the type of the two things that are part of the bunch object? So there are two things in this bunch object.
Series and data frame.
Yeah. So what are the types of these two? Okay, let's go over this. The type of iris would be type of iris would be bunch. And now when you want to get the individual things, what you can see is, target is there. That will be giving you the target column. And similarly, if you want to get the data, which is the feature matrix, you can access it like iris.data. Now, if I ask you the type of this iris.target and the type of iris.data, the type of iris.target is numpy array, correct? Similarly, if you see the type of iris.data, this is also numpy array, right? So generally, we want our data to be in the form of a data frame so that we can apply all those operations on our data. So there's one option in load iris and several other libraries as well. You can have this parameter as frame is equal to true. Okay, once you do that, now let's notice the types of all these things. The type of iris, as usual, is a bunch object. Now, if you check the type of iris.target, it's a pandas data frame, series, it's a column, it's a pandas series. And the type of iris.data would be a data frame, right? So this is the general practice if you want your data in the form of a data frame array. Although you can also convert it afterwards, but this is a quicker one, okay? Now, if you want to see the documentation of any library in Colab, what you can do is first to import that library. Sorry, it's a little slow somehow. Okay, so load iris is something that I want to know about. So what I'll do is I'll put a question mark and then I'll write the name of that very class that I want to know details of. So here on the right hand side, you can see different details of this library. As frame is what we just now used. By default, it is false, which means by default, it doesn't give in the form of data frame. Another option that you can make use of is return xy is equal to true. You can set it to be true. By default, it is false. So let's go over here and let's say I say return xy is equal to true. And what I can do is I can fetch whatever is coming in the form of x and y itself. So you see what I've done is I've asked load iris to return the data in the form of x and y itself so that you don't need to access them separately. So it won't return a bunch object. Now what it should return is, so let's see the type of x, it's pandas data frame, and the type of y is series, pandas series, right? So this is a quicker one. You can directly get the data and target in the form of x and y. Although you can do it yourself, like you can put x is equal to iris, x is equal to iris.data and y is equal to iris.target. You can do that separately from the bunch object. But if you don't want the bunch object, you can directly do this. So is this clear up to this point?
Ma'am, when we are using as frame as true, we are getting the target as a series. Can you please tell me what is this pandas series?
Okay, pandas series, you can see. Okay, what is pandas data frame before that?
It's a column like structure as we get in Excel or some other.
No, panda frame you can for table. two-dimensional table which has certain rows and certain columns. Okay, that's your data frame. Similarly, if you only look at one column, that's your pandas series.
Okay.
Okay, that's the difference. So has everybody reached till this point? All right, I hope that is done. Okay, iris that we had created. Now there's one more thing that we can do. Iris dot target names. Okay, now what it does is it gives you the names, different names available in the target column. Now, in the case of iris dataset, there are three different kinds of flowers details that is available in the dataset. Now, these are the names of those three flowers. So these are the three classes basically that this classification data contains. Now, getting back to our question. Getting back to our question, which of the following options are the class names in the iris dataset, right? So what should be the answer? We have just now seen
the second one.
Yeah, second one. We have just now seen that these three are the classes. So this should be the answer. Okay.
Ma'am, I have a doubt here.
Yeah.
This is the list of the class names, and we just checked out the labels. They are 0, 1, and 2. If I want to know which class name belongs to which label, 0 denotes which of these three classes, 1 denotes which of these three classes. What is the procedure of retrieving that information?
So it should be in sequence. So whatever sequence you see here in the target names, it should be in that sequence. 0, 1, 2 will be automatically assigned. And in case you want more details, you can open the documentation. Just say sklearn. So this should be provided as a part of that document.
No, I actually rummaged through the documentation. I couldn't find what I was looking for.
Yeah, so as I told you, this should be in sequence by default. 0,
Okay.
1, 2. Yeah. The whatever names are given, they should be in that sequence.
Ma'am, also one more question. Is there any pre-built function in this so that it can tell how many zeros, ones, and twos are there? So like dot count values sort of function, which we
Yeah.
have in NumPy.
Yeah. So you can actually make use of different functions. You can use pandas functions, or you can make use of NumPy functions.
So if we want to use pandas function, do we need to convert it into pandas data frame before this?
So see, it's about how you're comfortable. Sometimes there are some people who are comfortable using NumPy functions. There are some people who are comfortable using pandas functions. So they accordingly convert it back and forth. So that is a practice. Let's say you want to make use of a pandas function, you can convert this into from NumPy to pandas and vice versa.
No, my question is, it is already in pandas series, right? For example, in our target type of target is in panda series. So do we have to again import pandas and convert it into pandas data frame, or we can use pandas function on it directly?
So you're asking if you're making use of a pandas function, you should import pandas. Yes, you should import pandas.
And then we can directly apply it on our label data label.
Yes.
Okay.
If you're making use of a pandas function, you should import that, and then you can use all those functions.
Okay, thank you.
All right. The second question that we have is, so we can generate synthetic data using sklearn. So we have make regression, make classification, make block. So these are different classes that we can make use of. So the second question, if you see, we have to generate 200 samples with 10 features for multiple regression problems, right? With 10 outputs, and find the shapes of the feature matrix and the label vector. All right, so can you please do it using make regression, make underscore regression class you can make use of. All right, so what you would do it, firstly, you will be importing the library from sklearn. dot make regression is what you need to, sorry, sklearn dot datasets import make regression. So this is what you need to import. Now you would want to take a look at what is there in the make regression documentation. You can see the different parameters that you should be using. So in this case, what we want to do is we need number of samples to be 200. So let's fetch the data in X and Y and call make regression. Number of samples, you see, so the documentation you can take a look and accordingly you will make use of the parameters. Number of samples is equal to 200. And what else was given to us? Number of features to be 10. And it's a simple, it's a multiple regression problem. Number of features are 10 and number of 10 outputs, you know, multiple regression with 10 outputs, right? So what is the parameter for number of outputs? That is number of targets here. Okay. So we will be using all these parameters. So firstly, number of features. Is equal to 10, and then number of targets is equal to 10. Yeah, that's all we need. Okay, so this should be giving us the kind of data that we want. Now, what are we asking here? Find the shapes of the feature matrix and the label vector. So feature matrix is capital X. So we'll write, so how do we get the shape of any object? We'll write X dot shape simply, and it will tell us the number of rows and number of columns in that object. Similarly, we can write Y dot shape. So there are 200 rows and 10 columns as was given. 200 comma 10, and since it's a multiple regression problem, which means there are 10 outputs. Therefore, our Y is also of the shape 200 comma 10. So that is something to note here. So looking at the options, the first option is matching. So that should be the correct answer. Is that clear to everyone? Okay, I hope that is clear. Now let's move on to the next question. Find the shapes of the feature matrix and label vector for a multi-label classification problem. Okay, so multi-label classification problem, we have a library that helps us create data pertaining to a multi-label classification. So again, what we'll do is from sklearn dot, again it is there in datasets, from sklearn dot datasets import make multi-label classification. Okay, so this is the library that we need to import. Now in order to create the data, we would be fetching in X and Y, and we'll pass the required parameters. Now let's see what kind of parameters are we expected to use. Number of samples, you see 200 samples is what we want. And then 10 features, so number of features would be 10. 7 labels, and on an average 3 labels per example. Okay. Now you see, if you see the n labels, you know, this parameter, what it tells is the average number of labels per instance. So what is it? This is a multi-label classification problem. So every instance will have multiple labels. Now, how many average number of labels should an instance have? That is given by n underscore labels. Okay. So that is one parameter that we will be using. And what else is given to us? 10 features, 7 labels, and on an average, 3 labels per example. All right. Okay. So firstly, number of samples. It is 200. And number of features is 10. And on an average, 3 labels per example. N labels will be 3. All right. 7 labels. So that is given by number of classes here, right? Which is default 5. So n classes will take as 7. All right. Okay. So what we want here, shapes of feature matrix. And shape of Y. All right. So the shape of X is 200, 10 and Y is 200, 7, which is the first option. So that should be the correct option.
Ma'am,
Okay. Yeah.
ma'am, I cannot understand that on an average, the 3 levels per example. That part.
Okay. So do you understand what is a multi-label classification problem?
Yes, ma'am. I mean, we will have more than one column in the output matrix.
Correct. Correct. So you're synthetically generating data. So you need to have control over, on an average, how many labels should be assigned to a particular instance at a time, right? So, okay, let's say, this is first column and there are some features, feature 1, feature 2, feature 3. And then there are some, this is a multi-label classification problem. So let's say there are, okay, we'll take the same thing, 7 labels, okay? So label 1, 2, 3, 4, 5, 6, 7. Okay. Now these are the titles. Now let's talk about the first instance. First instance has some value for feature 1, some value for feature 3. Now out of these 1, 2, 3, 4, 5, 6, 7, how many should be positive classes on an average for a given sample? Let's say this is 1 for my sample, next is 0, next is 1, next is 0, next is 0, next is 1. Okay, 1, 2, 3, 3 ones, and rest are zeros. Yeah. So on it, so you see how many ones are there? There are 3 ones, correct? Now, if you take another sample, there'll be some values, and so these are the output labels. They could be 0, 0, 0. Okay, if you don't provide this number of labels, average number of labels, it could be that your instances are like this, right? Because it is synthetically generating. This is something you don't want, right? All zeros. You want on an average 3 ones to be there. There could be 2 ones because it's on an average. In the next one, let's say there could be 4 ones. There could be 4 ones like this, but there won't be samples like this. It's very unlikely that there would be samples like all ones or all zeros or close to that. This is something that you don't want, right?
Yes, ma'am.
Or this thing where there are all zeros. I mean, we want to have more control over the data that we are generating. So it's a good option at hand, right? This is something you don't want. So you have given this to be 3. Similarly, if you give it 1, your data would be something like 1 0 0 0 0 0 0 0 0 0 1 and so on. Did you get that?
Yes, ma'am. Now I got it. Yes.
Okay. All right, getting back to the next question, which of the following functions can be used to load the diabetes data set? Okay. Now tell me which is the correct option here. So here we are using as frame to be true and return xy to be true. Okay. In the second one, return xy is false, but we are fetching in xy. This seems to be an incorrect one. This one. We are asking return xy to be false, but we are fetching in xy. This will be giving you an error. So this is incorrect. And this is of course incorrect. This is incorrect. So the only correct option is this one.
Ma'am, what does as frame do?
As frame. So by default, the data that you get is in NumPy array form. Okay, the data type, as we just saw in the beginning, the data type was NumPy array. If you don't give as frame to be true, your data, the type of iris.data will be NumPy array. If you want it to be data frame type, you give as frame to be true. Okay. What are the data types of feature matrix and target matrix in the diabetes dataset as downloaded in the previous question? This one. So as if you download it like this, what will be the type of X and Y? We just now saw that. Can you tell me?
Data frame.
Data frame and X will be data frame and Y will be series. Correct? Data frame, yeah. Data frame and series will be the correct option. Okay. Okay. Now moving on. Okay. Which of the following options can be the output of the following code? So here we are making use of make blocks. Why is make blocks used? To create which kind of data set? Clustering data. Okay. So make blocks is used for that purpose. Now, what are the values that we are passing? Number of samples we want to be 10. Centers we want to be 3. What does the centers mean here? So again, as I said, you can go to the documentation of the library and you can see what these different parameters mean. So centers, the number of centers to generate, basically the number of clusters that you want. So that's what it does. Number of features are 2. Now, can you tell me what will be the shape of feature matrix? So there are 10 samples, which means there will be 10 rows, correct?
10 2.
And there will be 2 features, correct? So this is something you should not get confused with. Number of features will be the number of columns in your feature matrix, whereas the centers means the clusters. So this will not affect your shape of feature matrix. So 10, 2 will be the shape and the first option should be the correct one. Okay, so that was the set of practice questions. The graded questions go in a similar manner. Now let's do some questions and code. Then, so I'll give you some tasks and you will be coding, and I'll help you do that.
Ma'am, 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 how to access the correct data set of the cancer data set?
One second. Yeah, please repeat.
Ma'am, how to access the correct data set? Because in the cancer data set there are different kind of versions. So I'm not able to find the correct one.
How much noise can? One second. Yeah, you get the, can you?
Yes, ma'am. Ma'am, how to access the correct data set for the cancer data set? Because I am not able to access, find out the correct one because there are different versions of the breast cancer dataset.
Okay, which question are you talking about? Is it in graded?
Yes, ma'am, in the one graded one.
So it
First
should
one.
be,
I just want to know the correct dataset. I do not want any kind of answers because I'll able to find, but the finding the correct dataset is the critical. Otherwise, I'll be landing in the different answer set.
okay, there are different versions of different data sets. Firstly, if
Yes.
you're looking at it from point of view of answering some assignment, of course, it should be mentioned in the assignment.
Yes.
This noise from your side.
Because in the question number 4, 5, 6, it is clearly mentioned that which data set. It is clearly mentioned.
In the first question also it is mentioned.
No, ma'am. It is mentioned that the viscosine breast cancer data set, but there are different versions of this data set.
From sklearn.datasets?
Yes, ma'am. Ma'am, UCI learn.
No, from sklearn.dataset, there is only one version.
Okay.
Correct?
I found it the UCI dataset.
UCI also has a version. See, if you also talk about, let's say, digits dataset, there'll be a version in sklearn, there'll be a version in UCI, there'll be some other version in some other place. So, and the number of samples and features will differ. So, if it is an assignment, it should be mentioned to you which should be the source of your data. Like here, it is mentioned, you use that only.
Okay. Means I do not have to use UCI one.
No.
Okay. Thank you, ma'am. I was confused in that only. Thank you so much. And now I am able to solve it.
Yeah, if you're expected to use UCI, it should be mentioned in the question.
Okay. Thank you, ma'am. Thank you so much.
Okay. Yeah, can you mute yourself? Okay. All right. So I want you to, like just now we loaded the iris data set. I want you to load diabetes data from sklearn, just the way we just now did. And I want you to tell me the types of X and Y. Please let me know once you're done with that. And if you're not able to do it, please ask me.
It's in dimensional array, NumPy array, X and Y.
Hello.
You are not available.
Oh, I'm so sorry. So sorry. I should repeat them. So sorry. Okay. I don't know what all you missed. So when you don't give as frame to be true, the type of X and Y was NumPy array. Whereas when you give as frame to be true, the type of X and Y will be pandas, data frame, and series. Please note that as frame will not affect the type of data. The type of data will always be util bunch Okay. So I hope everybody is done till this point. Type of X is data frame, type of Y is series. You can also access the columns of a data frame by simply writing X dot columns. Okay. So X dot columns. So X, what is X? X is our feature matrix. You want to access its columns. It will give you the names of the columns. It is a very useful property that we would be needing whenever we are handling any data set. So it simply returns a list of the column names, X dot columns. I hope
Ma'am,
everybody.
Ma'am,
Yeah, go on.
hello.
Aisha.
Yes, ma'am, how we are getting X as feature matrix? Like, I was not able to see what you wrote.
Okay, so this is the first step. We import the required library, load diabetes, and then you create an object of load diabetes. And then there are certain parameters to that. If you don't give any parameter, you can simply go ahead. When you do that, you get this data object which will contain your data, and the type of this data will be bunch object. What is a bunch object? It has two things, data and target. Okay, you can access them like this. This data is what is your feature matrices. So you put that in capital X. So this capital X is your feature matrix now. Okay, and this target is your target column, whatever will contain the output. Okay, so that is your small y. This is general convention to keep them as X and Y. If you see the type of X, it will be we did not execute this. So we are not passing any parameter. The type of X will be numpy array. Similarly, the type of Y will be a numpy array. If you want to handle the data in the form of data frame, which is a usual practice, many people want to have their data in the form of a data frame, you give as frame is equal to true, which will not affect the type of data. That will remain the bunch object as usual, but the type of X and Y will change to data frame and series. Okay, I hope this up to this point everybody is clear. Okay, this is data frame now, and Y is also data panda series. Okay, I was telling you that you can access the columns by simply writing X dot column. So that's how you can do it. Okay, now.
Ma'am, I have a question here.
Yeah.
Can you use return xy equal to true for this question?
Yes, very well. You can use, whatever properties I told you, you can use for all load underscore whatever. There are some 6-7 data sets like this. You can use all these properties on each of these data sets. Okay.
Okay.
Ma'am, one more question.
Yes,
so we can use as frame equal to true, or we cannot use it also. But like, is it good if we is it good if we use it every time?
Yeah, if you want it in the form of X and Y, you write it every time. No problem there.
Okay.
Ma'am, this like data is a feature matrix.
Yes.
And data.target is label.
Target label vector.
Okay.
So you can do it return xy is equal to true. Okay, one more thing maybe I can explain you. So now what I did is return xy to be true. Okay, and I'm fetching this in same one object, data object. Okay. Now do you see this? Can anybody explain why is the type tuple now?
Because data has both X and Y values.
Correct. So data has got X and Y. So now if you write data 0, this is your X. If you write data 1, this is your Y. So if you're fetching it in one object, it will become a tuple. Whereas if you fetch them in X and Y, it will directly go to X and Y. Is that part clear? It'd be nice if you play around with all these things. They will be quite useful.
Ma'am, is it a multi-label data?
No, this is not. This is not multi-label.
Ma'am, if we don't use as a data frame, so we will be not able to use the different functions like the head function or info function.
Yeah, head and info you won't be able to use.
Yes, because I was trying and I was not able to use it.
Yeah, because they are part of pandas. That's why this as frame is provided. You can make it true and you can have everything in the form of a data frame, or you can convert an numpy array into data frame, right? You can explicitly do that if you want to make use of head.
This will be more handy if you
Yeah.
go in the data frame format.
Yeah.
Thank you, ma'am.
Okay. Next task, what I want you to do is, so OpenML you might be aware of. It's a repository of ML data sets. So you can download different data sets from OpenML by using the ID of the data set. So let's say the diabetes data set we want to download from OpenML. So every data set has an ID in OpenML, like diabetes itself is the ID of the diabetes data set. We discussed it in the last session, how we can download data from OpenML. We can make use of fetch_OpenML. It's a class in sklearn.datasets itself. So I want you to fetch this data. So this link is provided to you just for you to take a look at the data details. But if you know the ID, which is diabetes itself, you can simply load it. You can also skip this version. There are different versions in OpenML. You can skip this for now. So I want you to use fetch_OpenML and fetch this data. This is the ID of the data. Load it from OpenML. And tell me the number of features and number of columns in this data. Please let me know once you're done, or ask me if you have any doubts. Okay, so the first thing that you do is import this library from sklearn.datasets, import fetch_OpenML. Next thing is to create an object of fetch_OpenML. We can again make use of return xy to be true and fetch it in x and y. The thing that we pass, the first parameter is the ID, which is diabetes in quotes. So x gets the target, x gets the feature matrix.
Where do we get the ID from?
Yeah, you can go to this link and the ID you can see there. That's one. Whatever link I had given you.
Okay, the name is the ID itself.
Yes, that's the ID.
Okay.
This link. You can Google also OpenML and then diabetes. You write, you will be reaching that page itself, and you will get the ID there. This is truth for any data set that you want from OpenML.
Okay.
Yeah, like I have written, this is another ID of a data set. You can just play around. Mice protein, this is another data set having this ID. You can check and explore that data set as well. So what is the shape of x and y that you're getting? Did you reach this till this point?
Yes, ma'am.
Okay, good. Now can you tell me, is it a regression data set or classification data set? Let's say we don't know anything about this data. Can you play around with the x and y that you got and tell me what kind of data set this is?
Classification, regression, I think.
Okay, how did you check that?
Because one column like y.
Okay, all right. So X and Y, X is your data frame. You can apply all sorts of data frame functions on X and Y as well. Let's say we can write X dot info. Okay, it provides you basic types of different columns and the number of values in each column. So these basic details you get. And Y, if you write, so this is your Y. Okay, there are 768 rows in Y. Now, if you write Y dot unique, okay, it tells you the unique values in Y. Simply, you can write this. There are 2 unique values. This tells us that this is a classification data. Okay. As I said, you can use all functions of data frame. You can check X dot head, tail, all those functions you can use to explore. Now, can you also, since you have done this, can you explore this dataset mice protein and tell the shape of the data of the shape of the dataset?
Excuse me, ma'am.
Yeah.
Ma'am, when I'm writing y.info, it is showing an error that the series object has no attribute info.
Yeah, that is for a data frame.
Okay, so I can get it for X only.
Yeah.
And for Y, I can use this unique method.
Yeah, unique method, or there are other methods also. Depends on what exactly you want to see.
Ma'am, one more thing.
Yeah.
Ma'am, when I fetch this data, then it's X dot shape, it's showing 442.10 and Y dot shape is 442. But it's showing different for you.
Yeah, because it's a single label data set, right? Are you talking about diabetes or mice protein?
And diabetes.
Yeah. Okay. What are you getting?
442, 10 and 442.
You use this statement, is it? Or something else?
Ma'am, I use this only.
Okay. So it might be possible that there are different versions of diabetes data set. Can you try writing version is equal to 1?
Okay, ma'am. After that XY? Oh, no.
No, here inside. Can you see this? Inside.
Yes, yes.
Let's see what you get.
Version equal to 1. Ma'am, same. It's showing 442.
See, the data sets that you get on OpenML or even on UCI, there are different versions of those data sets. So that might be a possible reason. Is everything else fine? The Y values, what are those?
And there are so many 441 values are there.
I would like to take a look at the screen, your screen, but I think you might not be allowed to share your screen. Sorry, what are you getting in Y? Can you write Y dot unique? Can you write?
Yes, ma'am. I wrote y dot unique. Now it's saying bound method series dot unique of 0, 151.0 and 175 to 141.0, something like this.
Is this using fetch OpenML, right?
Yes, ma'am. Ma'am, it's showing an array of so many values.
No, this can't be. Yeah, somebody was saying something.
Ma'am, that's what I was facing problem in the graded assignment. Means I was getting different kind of data sets. And
oh, you can tell me which question. We can see if there is any difference in the data set.
I was finding in the graded assignment question number 1.
Question 1 is sklearn. It's explicitly written using sklearn toy data set. So that would be same, right?
Okay.
If you use sklearn dataset, you will get the same values. I think that's again diabetes data set, right? It's breast cancer data set. Yeah. So you have to use sklearn dot datasets, as in you have to load data which is a part of sklearn. You don't have to use UCI or any other source that is explicitly mentioned there. So you will get the same value. But here, what Aisha is telling is, despite using fetch OpenML, she's getting different values. Correct?
Yes, ma'am.
This is weird because you're using version 1, right?
Yes, ma'am. Version 1.
Okay, Aisha, do one thing. I want to take a look at your code. So can you start a discourse thread there, and I'll answer there only. You share the code, whatever you're using. Okay.
Okay, ma'am.
Yeah, let's discuss it there. Should be the same. What about others? What are the shapes that you're getting here?
Ma'am, I am getting 768.
Okay.
But if I load the sklearn dataset, import load diabetes, that dataset has 442 features.
Okay. Low diabetes you don't have to use. Are you, Aisha, are you using low diabetes? Low diabetes is a different
No,
version.
ma'am, I'm not using load diabetes.
Okay. Yeah, low diabetes will be a part of sklearn that would have, or that would be a different version. Okay, this one fetch OpenML uses OpenML data. That would be a different version. So it has to be explicitly mentioned in the question if the question is asking you the shape. So here it should give you this. If you're getting something else, we should check that out using fetch underscore OpenML. Okay. I think everybody else is getting these values.
Yes, ma'am.
Okay, good. Let's go on then. So now what I want you to do is I want you to generate data synthetically. You should generate a regression data set with these properties, 500 samples and 1 feature. Let's do that. Let's create the data first, and then we'll visualize it. Please let me know once you have generated the data. So you have to load this library from sklearn.datasets again, import make underscore regression. So we want 500 samples and 1 feature. We'll write number of samples to be 500, number of features to be 1. Have we done till this point?
Yes, ma'am.
Okay. So let us try to visualize the kind of data that we have created. So Matplotlib data visualization will come later, but for now, just to be able to see this data, we can do the bare minimum. So matplotlib.pyplot is the library that we can import to visualize. Seaborn is another one. So let's use Matplotlib here. So write import matplotlib.pyplot as PLT. We'll use PLT after this. And there's a function scatter in PLT. We'll write plt.scatter x comma y. So this kind of data we have generated. Please try to visualize the data that you have generated. Did you get this?
Yes, ma'am.
Okay. Okay, is everybody done? Shall we move on?
Ma'am. Hello.
Yeah, tell me.
Ma'am, that last question that I was facing problem, actually I was loading it in data. I was not using two different variables. That is why, yeah, I was not getting.
No, that should be same. If you are loading it in data, then data and data.target is what you would be using, right?
Yes.
Shape, so it should remain the same, correct? Are you getting the same shape now?
Yes, ma'am. Now I am getting the same shape.
Okay, fine, good then. All right, so this is the kind of data that we have generated. It's a regression data set, simple linear regression data it is, right? There is a parameter in make_regression to introduce noise in this data. So you see, this is not sort of a real world data. This is entirely on cross linear line. So we can introduce noise into this data to make it a little similar to real world. There is a parameter noise in make regression, and we can give some value to it. By default, it should be 0. More the value, more the noise. Noise is equal to 0, you see. So by default, it doesn't introduce any noise. And what does this mean? It's a standard deviation of the Gaussian noise. So whatever value you give, that is the standard deviation of the Gaussian noise that is introduced into the data. So you can play around and giving more values to it. I want you to give noise to be 10 in the same data, and then I want you to visualize the data. So you see, this is the kind of data that I'm getting now. This is not entirely linear. There is deviation now.
Can you show the code for this?
Yeah, just only add noise is equal to 10. I've also added one more parameter. This is not needed. Simply run this, and then I did not. Okay, I'm fetching coefficient also. So what I was doing was fit a line and give me the coefficient of that line also. This is not required at this point. So let me remove this. So I now visualize it. This is the kind of data. Now, if you try increasing this noise, let's say I make it 25. So now your data is more scattered, right? So you can just see what kind of data you want, so that it becomes not so easy for any model to predict, right? So you can use this parameter. Okay. All right. I hope everybody is done till this point. Let's move on. Any doubts so far? Okay, good. So far we synthetically generated regression data. Now let's generate classification data by making use of make_classification from sklearn.datasets. So the properties that I want you to have is number of samples. I did not mention. You can take them to be any number. Let's say 50. Take 50 samples. Two features, two classes. I hope you all went through the lectures by now. It will be a good idea to go through the lectures before the live sessions. Okay, if you look at the documentation of make classification, there are various features. One note that I would want to highlight is there's a feature, there's a parameter number of features. By default, it is 20. There's another parameter number of informative features. So in a real world data, what happens is many features are there, but they might not be informative. That is, they don't have any, they don't add any value in prediction. So that they are number of informative features. So they are redundant features. So informative is opposite of redundant. So you can mention this in your data. If let's say 20 is the total number of features, by default number of redundant features is 2, which means 20 minus 2, 18 features would be useful features, or you can say informative features. So your number of features should always be number of informative plus number of redundant features. This equation you should keep in mind.
Ma'am, this redundancy will be depend on the correlation matrix, no?
Yeah, correct.
Miss, as the miss, it was in the one of the lectures also, miss, data visualization part.
Yes.
Okay.
Yeah, so if there's a high correlation between, let's say, two features, they will be redundant, right?
Yes,
they
ma'am.
don't provide any extra information.
Yes.
So number of features, what you should note is, it is the total number of features. It comprises of number of informative, this one, number of informative features, number of redundant features, and number of repeated features. Okay, and whatever remains. So what I want you to say, I want to tell you is, let's say you give number of features to be 2. Okay, now a number of informative is by default 2, number of redundant is by default 2. Sum of informative and redundant is 4. So number of features which you have given to be 2 is less than the sum of informative and redundant. You will get an error in that case. You can try this right now. So you should make note of this thing. If you want total number of features to be 2, you should explicitly specify that your number of redundant features should be 0 and number of informative should be 2. Okay, let's get back to our question. What I want you to do is classification data you have to create with 50 samples, 2 features I want. Since I explicitly am telling you to create 2 features. Now, if you do not provide any value for n repeated, n redundant, which is 2 by default, you will get an error. You can try that out. So what I'll do is, I'll give number of informative to be 2, which is default 2. You can skip this part. Okay. Number of redundant is by default 2. I'm giving 0 explicitly. So that should be fine. Next thing I want is 2 classes. So I'll mention number of classes to be 2. 1 cluster per class. So number of clusters per class is another parameter. I'll give that to be 1. Random state, wherever random state is to be given, it's a good idea to give that so that you get all the same results. Since you see there is randomization involved, even in make regression, there was randomization involved. So it was a good idea to give the value of random state there also. Okay, you please generate this data and tell me the shades of X and Y. Please let me know once you're done.
Done.
Okay. What is the shape of X?
50, 2.
Y?
Because we have 50
Y. I
samples.
said shape of Y.
Y 50.
Correct, correct. Has everybody done, or is there any doubt?
Ma'am, what's the meaning of one cluster per class?
Yeah, so, you know, do you want a clean data or not so clean data? So like we introduced noise in regression, in the case of regression. So here also, if you give a value which is more than 1 for number of clusters per class, there'll be different clusters. You know what is cluster, right? You can visualize that. There'll be different groups of data points pertaining to that class. The data will be not so clean, as in the data will not, all the data pertaining to one class will not be one clearly defined group. If you give more than
It
one
will be
value,
scattered around one.
scattered,
one
more
class.
scattered, yeah, depending on what value you pass over here.
Okay.
Okay, can you visualize this data that you have generated for classification? How many of you have used Matplotlib so far? Okay, we just now showed a usage of Matplotlib for using plt.scatter we used, right? You can again make use of plt.scatter, but you have to see now in the regression data, we had only one feature, correct? We had only one feature, so it was straightforward. This was your X and this was your Y. Now in classification, you have two features. So what you want is, you want to see the data. Your x-axis could be the first feature, your y-axis could be the second feature, and your data points you want to see whether they are sort of linearly separable or not. So I want you to have first feature on x-axis, second feature on the y-axis, and visualize the data. Can you do that?
Ma'am, can you show the code for line 25?
Yeah, of course, I will show. So again, we are using plt.scatter. Now on the x-axis, I want this. What does this mean? From X, I want all the rows. This is what the colon is telling. All the rows and 0th column. This becomes your first feature, right? Is that clear? Similarly, X, now this represents your second feature values. I want all the rows, but the first column. This is 0th column, this is first column. So this is your second feature. This goes on the x-axis, this goes on the y-axis. Then there are different properties that you can make use of. There's no ending. What kind of marker do you want? I want a circle. C is for color. So data visualization is covered elsewhere, but I'm telling you the bare minimum. You can skip these three properties if you want, but let me tell you what they mean. C is for color. I want the color to be pertaining to Y. If Y is different, there should be a different color. So that should tell me which data point pertains to which class. S is for size of the marker. You can change it. Edge color is the edge color of the marker. So these are just beautification properties. Once you run this, you get this kind of, run all this. So this is the kind of plot that I'm getting. So,
Ma'am,
yeah.
what will happen if I use -1 in place of the 1? In
Here?
the yes.
What does -1 mean? -1 pertains to the last column, correct?
Yes.
So that should be fine as well.
Okay. So means
in this case, because there are only two columns, right? The index of the second column could be either 1, right? Starting from 0, the index of the second column would be either 1, or you want to start backwards, -1 would be pointing to the second column. So that should be fine, no problem.
yes. Okay, thank you.
So you can just play around with these properties if you want. And then edge color, if you want to change, you can just check, right?
So ma'am, what does K represents? K means
Where is K?
in the edge color you used earlier. You used K, and now you are using B.
K was black, B for blue.
Okay.
You can completely write also. You can write the full name also.
Ma'am, can you please explain the C equal to Y again? What is that?
So C is for color. So what color? Let me remove this. What color do you want for the marker?
Oh,
Now let me run this. So you see all the data points will be of the same color because we have not provided any extra information, right? Now what I can do is C is equal to some list. I can pass any list, but the size of that list should be the size of the number of rows, size of this thing. Okay. Now Y is something that is of the size, this thing, and Y has different values. Y has 0, 1, such values, right? So 0 will be assigned one color, 1 will be assigned another color. So that's what it does. Is that clear? Okay, shall we move on? I now want you to create clustering data with these properties. Let's say uh, 100 samples you create. It's not mentioned. Let's create 100 samples. I want you to have 2 features in the data, and there should be 3 clusters. So which library would you make use of to create clustering data?
Blob.
Yeah, make underscore blobs. Correct. From sklearn.dataset itself.
And can you show the code for above scatter plot?
Ma'am, is it possible to share these codes in this file, this code file?
Yeah, I can do that, sure.
So from where we can access?
Wherever you get the lecture notes.
Okay, in the
right?
supplementary content.
Supplementary section, yeah.
Okay, thank you, ma'am. Thank you.
Is this done? You can go to the documentation. You can see what parameters are needed to be able to generate this kind of data. Or you can put a question mark here in Colab itself and then see the details on the right hand side. Okay, so I hope you have imported this library, sklearn.datasets import make underscore blobs, and you can mention. So if you don't mention, it will take the default number of samples. You can see what is the default number of samples in case of make blobs. Should be 100. Yeah, it is 100 already. So I'm mentioning number of features to be 2, and centers is what is used to mention the number of clusters. Centers is equal to 3. This is how you can generate X and Y. Now, I want you to visualize this again in the similar fashion by using plt.scatter. And since there are 2 features, again, you can do this X colon 0, X colon Y, and then marker. You can see different markers also. Let's say I don't want a circle, I want a diamond. So this capital D. If you want a star, you can put a star. The different options are there. Similarly, I want to see which data point belongs to which cluster. So I'm giving C color is equal to Y as before, and size I'm giving, and I'm giving the edge color. So this is the kind of data that I'm getting. Just like that, increasing the size. So see the colors. You see the since I've given the star, and I've given the background, not background, edge color to be black. It's actually not so clearly visible. So I'm removing that, and now you can see by default the edge color will be same as the color of the marker itself. So you see all the 3 clusters in different colors. Did you get this?
Yes.
Any doubts so far?
And what does S is equal to 45 denote?
Size of the marker. Just like that, doing so that you see. Okay, one more thing, we did not mention the random state, right? So we are getting different values in every run, right? If you give random state value, then you will get same values across every run.
Does this graph is showing 3 clusters for 2 different features? Is it like this?
Yes, 3 clusters, 1, 2, 3 clusters, and 2 features. One feature is on the x-axis, the other feature is on y-axis.
Okay, thank you.
Ma'am,
Yeah.
ma'am, the make blobs, there is another feature called cluster standard, right?
Cluster, the standard deviation of the clusters, correct.
Okay. So
what that means is how much scattered your data point should be in a given cluster. Okay, if you increase this value, your points should be more scattered.
scattered, yes.
Yeah. Do you see the difference? I've given a way high value for cluster standard deviation. By default, it is 1. Now, when you give 10, you see what happens. The standard deviation, or you can say variance, increases. Right? Let's give it 2. So when you give it 1, they're close enough so that you can clearly identify the clusters. But as you keep increasing its value, they are more away from each other. You see?
Yes, ma'am. Yes, ma'am.
Has everybody done till this point?
Yes.
All right, let's move on. There are so we used different examples of loaders: load iris, load diabetes. There are many such data sets, which are small data sets, also called toy data sets. They're a part of sklearn library. They're not very huge. There is another option to load data using sklearn, is fetching the data sets. So there are again different um, uh, classes that we can make use of. They're called fetchers. So you would have seen that in lectures. There are different IDs that we can use. So what you can do is fetch underscore dash. There'll be different keywords that you can use over here. So here I want you to download this KDD cup 99 data set using a fetcher. Okay. So what you have to import is sklearn.datasets. You have to import fetch underscore KDD cup 99. So as I said, there are different keywords that you can make use of. For some other data set, you can check the details in sklearn API about all the features that are present. KDD Cup 99 is a data set which was created as a part of KDD conference. Knowledge data mining. There is a very popular conference on data mining topics. So in 1999, this data set was created there, and then it became part of sklearn library. So fetch this data and examine the shape of X and Y and tell me whether it is a classification or relation data set. It's a little huge because it's not a toy data set like iris or diabetes. It might take a little few seconds to load. Please let me know if you have done it or if you have any doubts.
Yes, sir.
Okay, good. So after importing the library, we have created an object of fetch underscore KDD cup 99. Again, the type would be bunch as before.
And the shape of picture is 4,94,000.
Yeah, correct. So it's a huge data set, you can see. And if you have to see the feature names, you can make use of KDD data dot feature underscore names. Okay. You can see these are the different features in this data set. This is the shape, data dot shape. Target dot shape will be this shape. Is this clear? Has everybody done till this point? Okay, this is a NumPy. Okay. It's a classification data, right?
Yes, ma'am.
Yes, ma'am.
Correct. All right.
But
And
ma'am,
how we are saying that it is a classification data?
If you see, so this is if it was a regression data, there would be numerical values here, correct?
Okay. Okay.
Another
Got it.
option to check is, let's say you fetch your data in the form of a data frame. You mention as frame to be true. Then your data and target would be data frames. And then for this data frame, what you can write, target dot unique. It will give you all unique values like we did earlier.
Yes. Yes.
Yeah.
Okay.
Okay. There is another toy data set. Any question?
yes, ma'am. Here we are only seeing that B normal. So is that? I mean, I can understand that is classification, but should at least have two values, right?
Yeah, because you're seeing only how many values? 1, 2, 3. You're checking initial few values. It seems an imbalanced data where one class is more represented than other classes.
Okay.
You can actually check it out. You can see, and then you can actually plot also the distribution of different classes. Okay, I think we did this in end-to-end ML collab. So what you can do is you mention as frame to be true, and your KDD data dot data will be frame data frame. Okay, and your KDD data dot target will be series. Then you plot that the distribution. You can also see the unique values. You would see other values than normal. You would see many other values. It's just that it's an imbalanced data, so normal is much more represented than other quite less represented classes.
Ma'am, is there a way to count the number of unique classes?
Yes, you can do that. There are many functions in data frame. So in pandas, I am saying there are many count values is one function that you can make use of, and there are functions in NumPy also. If you want to see the distribution of different values or classes in this case. So that is why it's a good idea to be well versed with both NumPy and pandas at this stage itself if you're not. I think NumPy is provided as a part of week 0 in MLT, right? Did you check that out?
Yes, ma'am.
Yeah, NumPy is provided there, and pandas also. If you're not if you have not played around with it, it will be a good idea to do that before you go on to the subsequent weeks. Okay. Okay, so similar to iris data, there is a wine data set in sklearn library. Can you tell me whether it is classification or regression data? So you can make use of load underscore wine.
And classification.
Okay, has everybody done it? So these are the values that you get in target. No, it's not a regression. It's a classification data. Everybody got this? All right. So this was basically similar to iris itself. So nothing there. Okay. I think we did this in one of the questions in practice assignment. Make multi-label classification. So just try using make multi-label classification with 500 samples and 2 features and 5 classes. Try playing around with this library as well. Please let me know once that is done. Is this done?
Yes, ma'am.
So you see here 500 samples, 2 features, number of classes 5. So if you see the y variable, this is the kind of y variable that we are getting. We did not mention the average number of what was that variable? Not graded. Practice assignment. We discussed this a while ago. Average number of labels, correct? Average number of labels. We mentioned 3 explicitly here, and I told you what difference does it make. We have not mentioned that over here, which means we'll take the default value, which let's check, make multi-label classification. So let's see the default value for average, which is 2, right? Average is 2. Average number of labels per instance, we have not mentioned here. So we'll take 2. Number of classes we are mentioning to be 5. So some have zeros, some have all ones. So on an average, it will be 2. Here we have 2. If you check all, then the average will be 2. You can change that value if you want. Okay, this thing, and all right. Now, so far what we did was we either made use of data sets from sklearn, or we fetched some data from an online resource like OpenML using sklearn, or we generated data using different classes in sklearn. If I ask you to generate data manually, can you do that? Again, that would require you to be proficient with NumPy, right? Would you be able to generate, let's say I want you to generate the classification data manually. Don't use any libraries that we have used so far in this session. Just make use of NumPy, and let's say 2 class classification data you have to generate. Make use of random function. Would you be able to do that? You should be able to do that because sometimes you do want to quickly generate some data, although that will take some time as compared to these libraries. These libraries are quick. Make classification, make regression will quickly generate data for you. But it will be a nice idea to create data yourself as well by making use of certain functions like numpy.random.normal, numpy, and then reshape. Okay, I want you to try this quickly, and then I'll explain how you can do that. Please spend some time, make use of NumPy function that you would have learned in MLT week 0, and then we will see how we can do that. Okay, let me try, let me explain to you how we can manually generate data. So I'm importing NumPy explicitly as NP. So we are going to create data for classification. So first I'm creating data for class 0. So, we have to first create capital X, that is the feature matrix, and then the target column, that is Y. So let's go one by one. We'll create X. We will have to generate some data pertaining to class 0. So I'm making use of numpy.random.normal. It randomly creates data points. Size you will mention as a parameter. I want to generate 100 data points which are normally distributed, right? So numpy.random.normal will generate 100 data points for you. Now I'm making use of reshape. I'm making use of reshape. Reshape is used to reshape a given list of values or array of values to a required shape. Now here I'm passing the shape to be -1, 2. -1 means we don't care, you decide. 2 I'm explicitly mentioning, which means dash number of rows and 2 columns, which means whatever data points we have, which is 100 in this case, I want you to convert it into dash rows and 2 columns. So when you divide these 100 data points in 2 columns, it means 50 rows, correct? So -1, I'm mentioning, either I can mention 50 over here, or I can mention one of the values and the other will be automatically decided to be 50 by NumPy. Now these are my data points. So numpy.random.normal by default generates data points between 0 and 1. I'm doing -5 here. Okay, I'll explain the reason behind that. Next, I'm generating examples for class 1. For class 1, it should be. Again, I'm making use of numpy.random.normal. 100 data points I'm generating. Again, I'm reshaping to the same value. Why? Because we want 2 features, right? I hope that is clear. We want 2 features and 2 classes. Now I'm doing +5 over here so that these data points are displaced by a distance of 5. So I'm doing -5 for class 0. I'm doing +5 for class 1. So there'll be a distance of close to 100. Why close to 100? Because this will be randomly generated. So there'll be some deviation across the points. So roughly there'll be a distance of 100 between the data points pertaining to class 0 and class 1. Now these are 2 different arrays, right? I want an X array, so I'll be concatenating these 2 values that I'll get. So I'll use numpy.concatenate, and here I'm passing the 2 arrays, examples from class 0, examples from class 1. So if you're not well versed, please see and understand how these functions work. There's another parameter axis which tells whether to concatenate row wise or column wise. So accordingly, you can mention axis is equal to 0 or 1. So you can see that. So this will concatenate, and that's what your capital X is. Now we have to assign labels. What we want to do is, for the initial this 50 points, we want to assign, let's say, class 0. For the next 50 points, we want to assign class 2 be 1. So labels for class 0, what I'm doing, numpy.zeros. It will generate a list of zeros of size 50. Similarly, numpy.ones will generate a list of ones of size 50. Then I'm concatenating them. Okay. This is again how I'm doing. In the list, I'm just passing these 2 individual lists and they will be concatenated. Let's see what kind of data we generated. This is our X. Okay, and this is our Y. Initial 50 are 0 and next 50 are 1s. Now let's try to visualize this data using Matplotlib. Again, same thing. Red circles we want. So we can do like this. You can also give C is equal to Y as before. Okay, that was in plt.scatter. There are different functions plt dot, okay, ro you cannot give. So there are different values that you have to give for different markers. So you have to see the documentation and see which parameters are allowed for which function. So earlier we were using plt.plot, that is also fine, but there are some extra properties in scatter which we are making use of. So you see these two different classes we are getting. These are the data points, and this goes from -8 to +8, roughly. That's the distance. You can play around and you can change these values over here. -5, you can make it -10 or something, and different properties of numpy.random.normal also you can use if you want your data to be in a different range. So you can do that also. Now let me also quickly show you how you can generate using Seaborn. So I'm using import Seaborn as SNS, and that has a function scatter plot. Matplotlib had plt.scatter. Here we have scatter plot, and this has one property: hue is equal to y. Instead of color is equal to y, we have hue is equal to y. So this kind of a little better plots we get. That's the property of Seaborn. You get so this is again a simple plot, but there are many complicated plots like pair plot and various density plots are there, which are quickly generated by using Seaborn. This is one example. Any doubts so far? Is this clear till this point? So we looked at different ways of loading data in our code. So obviously that's the first step to any ML modeling. That's what we did in this week 1. We now know if we have to build a model, we now know how to load data. We can either synthetically generate it, we can manually generate it like we did now, or we can load it from the set of toy data sets from sklearn, or we can fetch it from some source, like we can use different IDs like KDD, Cup99. There are other options also. Please take a look. They are there in the lectures, lecture videos. You can take a note, and you can fetch them from OpenML. One more way is there, I think that should also be added for the sake of completeness. There's another repository of datasets, which is UCI. So there are different datasets. Okay, let's use this only. Balance scale data, I think we'll be using in Saudi. So UCI has again different ML datasets, quite extensive data, repository it is, with different kinds of data, whether you want clean data or you want imbalanced data, you want data having categorical features or all numerical features. There are different filters also that you can make use of. So like we are looking at this data set, balance scale data set. This is the data folder. This is the data set description folder where you can get the column names as well. Again, there are different versions that you can come across. I'll show you that. And here you go down, you get to see where this data set is coming from. You can see the attribute details, and these are papers that use this data set. If you're using this data set, how you should cite. So those details are there, and these are the details like multivariate, categorical, classification. There are no missing values. There are 4 attributes, these instances. What is the domain, right? And what is the date when it was added here, and so on. How many people used it, and so on. Data folder, when you see there are different things. These are the names of the columns. Yeah, this is the data. Now, when you click it, you can download a CSV. Okay, you can download a CSV, or you can copy the link. Copy link from here, and then if you want to load it in your data, there's a function from pandas again that you can make use of. It's pd.read CSV. Let me import pandas as pd, and then you can write pd.read CSV. You see, this is the link to the CSV, and using pd.read CSV, you're able to load this data into your code, and then you can apply all sort of operations. This is a pandas data frame, by the way. The return type of this will be a data frame, and you can apply pd dot. Okay, you have to fetch this somewhere. Let's say data is equal to this. Then you can write data dot info. All right, so this is how you can load any data from an online resource as well. So these were different ways of loading data sets from different sources. I hope you're now prepared to go ahead and play around with these data sets. Any doubts so far? We can take them up now. Hello? Am I audible?
Yeah, ma'am. Yeah.
Yes, yes.
Okay, good.
Ma'am,
So yeah, Aisha.
ma'am, can you explain what is a multi-level classification problem?
Okay. Multi-level classification. Okay, what is the kind of data set that we saw? Iris data set. Iris data set had one column, right? And there were three classes. So what kind of data set that is? So let's start with the binary classification. Let's say, given some features, a person is diabetic or non-diabetic. Okay. There's one column, there's one target column which tells whether a person is diabetic or non-diabetic. So it's a binary classification problem. And every data point can have only one of these two values, right? There cannot be two values, or can there be? Can a person be diabetic as well as non-diabetic? No. So there can be only one possible target value. So this is a single label binary classification problem, correct? Now let's move on to Iris dataset. Iris had three classes. So it was not a binary classification, it was a multi-class classification problem, correct? Again, given a flower, given the dimensions of a sepal and petal length width of a flower, it would either be one of the three kinds of flowers, right? Setosa, versicolor, and whatever the third one is, virginica. Okay, it would be one of these three. Can it happen that a flower is both virginica as well as setosa? No. Correct. So only one value is possible. So again, what kind of problem this is? It's a single label multi-class classification problem. Is that clear?
Single label multi-class.
Yeah. Okay. Is that clear?
And label is the type of flower here. Yeah.
Label is how many labels can be assigned to a given data point.
Okay.
How many labels can be assigned to a flower here?
One.
Correct?
Yeah.
So it's a single label multi-class.
Okay.
Now let's move on. Let's say the data points are images of fruits, where every image has different fruits. Let's say, okay, let's limit it to three fruits. No, let's limit it to two fruits. Orange and banana. Okay, orange and banana. Every image could have both orange and banana. Okay, so the targets are, one target column we have for orange, another target column we have for banana. For a given image, if orange is present in that, we put 1 there. If banana is present in that image, we put 1 there. If only orange is present, we put 1 0. If only banana is present, we put 0 1. If neither of orange and banana are present, we put 0 0. Is that clear?
Yes.
Now there are two labels that can be assigned to a single image. Is that clear?
Yes, ma'am.
Now this is a two label or multi-label
Multi-label classification.
binary classification problem.
Binary. Okay.
Correct? Now let's
Yes.
say, again, let's say there are three fruits that can be there. If there can be three fruits, there'll be three target columns. Correct? Again, that would be multi-label, three label, and binary class classification. Why binary? Because there can be 0 and 1 in these individual cells. Correct?
Yes.
Okay. Now let's say, can you think of an example that is multi-class, multi-label? So it will be a multi-class when there can be 0, 1, and let's say 2, 3 more values that can be possible in each cell. All right.
Yes.
Let's say there are colors. Okay. What is the color of the fruit? It could be green. It could be yellow. So if you bring in that dimension as well, then it can easily become a multi-class, multi-label classification problem. Is that clear?
Yes, ma'am. Thank you.
Okay. Any more doubts? All right. If there are no more doubts, it seems things are clear. I would suggest you to start practicing if you haven't. With whatever we did today, it should be sufficient for you to get started into, having your data in your code. And once that is done, then you can actually start playing around with whatever comes in the subsequent weeks. So if there are any more doubts, we can take, or we can close it if you all are clear. Okay, good. That was an interesting session. Still, if you have any doubts, you can post on this course and we can take it from there. All right. Thanks, everyone, for joining in. Thanks. Yeah.